Central Building Research Institute, also known as CBRI, is a constituent establishment of the Council of Scientific and Industrial Research, CSIR. It has been tasked to generate, cultivate and promote building science and technology in service of the country. The national mission strives to meet the housing demands of the people of India by the year 2022. The conventional methods of building construction are not likely to meet targeted commitments. This requires a technical evaluation of new and emerging building technologies that are cost-effective, faster to construct, disaster-resilient, environment-friendly, aesthetically pleasing, and comfortable to live in. These technologies will set a direction that our future cities would follow. Besides, location-specific appropriate building systems, materials and components developed by CSIR, CBRI, many other R&D, educational and commercial organizations have also come forward with building technologies and systems. The CSIR Central Building Research Institute, Roorkee, India, is developing a common platform for full-scale demonstration and performance evaluation of promising building technologies as Construction Technology Demonstration Park.
A lot of easiness can come into the construction sector because of using this machinery, which include C-brick machine, which include cranes here, which include horizontal drilling machine and all those things, which also gets developed here. So these are all the various aspects that we are trying to address in this construction demolition park. And the 10 plots that are available here, we are doing to do that here is only a tip of the iceberg. We may have a choice for 100 more later on once this gets successful, and many industries have played a very keen role.
Demonstrated here is a fusion of construction technologies that offer a wide choice of options to industry, academia and researchers for mass housing projects under different sets of local conditions. The park currently showcases two-storied houses having a uniform layout with a total covered area of 1,100 square feet for each building. The bouquet of technologies demonstrated here covers a wide range of partially precast building components, use of locally available materials in a scientific manner, fully precast industrialized buildings, dry construction using steel framework with commercially available wall cladding materials, structural use of bamboo in buildings and integration of energy-efficient green building systems for both hot and cold climatic areas. The approach adopted introduces standardization in housing through modular coordination-efficient space utilization, climate responsiveness, energy efficiency, disaster resilience, and cost-effectiveness. These technologies will be subjected to rigorous evaluations of water tightness under cloud-burst simulation, to acoustics performance, thermal comfort, indoor-outdoor air quality monitoring, performance under axial lateral loads, fire resistance, and many such tests that are needed for safety, durability, and comfort of the users. The demonstration park has a host of emerging technologies to showcase. A few examples of these will be showcased now. This demo house, partial prefabrication techniques have been demonstrated that are more amenable to the construction system in India. The walls have been constructed using specially developed concrete blocks that have large irregular stones inside. Brick masonry in rat trap bond saves 25% bricks and gives a thermally efficient walling system. Precast roofing systems like the RC plank and joist system, precast channel system, brick panel system, L panel system for sloping roofs, precast stair units, precast door and window lintel cum sunshades have been used here. The house is safe against earthquakes even in Zone 4 and 5. Bamboo has very good mechanical properties and can be used as a good building material in the construction of houses. For durability, these bamboos have been chemically treated against insects, termites, fungi, and rot. The bamboo structure has been specially designed for required structural strength as columns, beams, trusses, staircases, and safety against earthquakes and winds. The bamboo wall panels have been protected against rains by ferro cement plaster on all exposed walls. This is a net zero energy house. Industrial wastes like fly ash have been used in the bricks that do not require coal for burning in kilns. Bamboo is used to replace steel in tie columns of confined masonry. It also demonstrates several innovative passive techniques for natural ventilation and to keep the house warm in winters and cool in summers. Natural indoor lighting and solar energy injection in the main power supply are likely to offset all but the little power that the house takes from the electric supply system, making it a net zero energy house. Here, coal-formed steel wall panel framing technology has been demonstrated. Cold-formed steel wall panels have fiber cement boards and gypsum boards on both sides. Rock wool is sandwiched between the gaps for insulation. These panels are the main axial load-bearing members in this system of construction. This system is environment-friendly and has a high strength-to-weight ratio.
This technology has various advantages over the conventional concrete technology, RCC construction. It is very fast to construct, it is very easy to construct. A G+1 story building can be constructed in maximum up to 10 days. This technology can prove to be very beneficial in providing the required number of housing units in the stipulated time.
Due to faster construction, easy transportation, and good thermal comfort, this system can be adopted in the earthquake-prone cold hilly areas. This is a dry construction technology where no water is used during construction at the site. The main load-carrying frame of the building is made of hollow steel sections, HSS, with strong monolithic beam column joints for improved performance. Bolted steel joints make the work at site easier and faster. Various types of wall panels available in the market can be used with this steel framework.
We have come up with different connector elements as you are looking in the first floor. So you can see 3-arm system, 4-arm system, 5-arm system and 6-arm systems. So also we have come up with the another systems, that is flange plate connection. You can see at the ground floor, that is in the blue color, that is a prefabricated connection. So these all the connections, beam column, we have fabricated on site or off site also we can do. So later on this whatever the fabricated system is there, that is erected on site within 8 hours, and after that whatever the system is there, that also we have tested and which is satisfying the requirements of the Indian standard codes.
By proper planning, a 2-story house can be constructed in about a week. Messrs. B.G. Shirke has demonstrated here an industrialized precast building system. Complete multi-storied buildings are pre-designed and industry-produced using high-quality RCC building components like columns, beams, walling and roofing components, stair flights and walling blocks. The components have specially designed connections that join to each other to construct a strong building in a short period of time. The structural integrity of the system has been evaluated by IITs and CSIR CBRI on various parameters. This is another house demonstrated by Messrs. Everest. Here the designers have used a hollow steel section frame to carry main structural and imposed loads. The frame is nut and bolt jointed, minimizing on-site assembly work. Their proprietary wall panels consist of an aerated cement concrete core sandwiched between two cement boards. This too is a dry and fast construction system. Several walling panels and finishing boards have been displayed here.
In this demo park, we are making one unit with 100% of replacement of natural fine aggregates with construction and demolition waste. Here we are making bricks like this and blocks for making the walls, and we are also using construction and demolition waste in making the columns, beams and slabs. The purpose of making this building is to evaluate its long-term performance and see the durability of concrete made with construction and demolition waste.
These buildings shall be scientifically evaluated for their performance under heavy rains, natural hazards like earthquakes, cyclones, floods, fire, indoor and outdoor air quality, and also comfort level in hot, dry, cold and humid conditions. Construction cost, construction speed, capital investment and public acceptance are important parameters that decide the success of a housing system. This demonstration park will help users, designers and builders to select the most appropriate building technology for their geoclimatic conditions. Through meticulously designed, researched and evaluated building systems, materials and components by the scientists of the CSIR CBRI, India is edging closer towards more scientific and technologically feasible solutions towards the fulfillment of the country's dream of housing for all by 2022.